Sorry. Installation. Kubernetes installation will be there. And there, as I said, there will can be multiple ways of doing the installation, in which I will write over here as well, multiple ways of installation. Correct? But in this, if you want to install, you can continue to use your kubeadm. One option is that. Other option can be, you can go and use one thing which is known as Minikube. Correct? So it's like a virtualized environment for Kubernetes, which you can use. So this is something which is a server deployment, which you call it as a bare metal installation. Bare metal installation. This Minikube is something like a virtualized environment for Kubernetes. Correct? Then one thing which you use on AWS, that is known as COPS, right? The one which you have seen on AWS is COPS. COPS is Kubernetes on AWS. Correct? Then if you are running Kubernetes on GCP, right? Let's say that its name itself is Kubernetes on GCP, right? Kubernetes on GCP. Correct? This is a Kubernetes running on Google Cloud platform. So multiple ways are there. Similarly, you can do it on your Azure as well. Kubernetes on Azure, and that will be similar to Kubernetes running on Azure Cloud, something like this, right? Or Microsoft Azure, whatever you want to call it, you can use that, right? Now, installation of the Kubernetes you can do from the link which I have done, right? Also, you can search for KOPS and COPS AWS, manage Kubernetes cluster on AWS using COPS, right? So here you can use, these are your Mac commands which you're using. So brew, update, install, COPS, version is this, curl, you can do this. Now what you're doing, this is basically why I'm saying this. This is, you are running on a EC2 instance, right? So don't get confused. So your Amazon EC2 full access you will give, Route 53 access you will give, IAM full access you can give, right? Then AWS S3 API, you're creating the buckets, right? And you're exporting the state of Kubernetes AWS. So these are your installation on the Kubernetes cluster, which you are doing using your EC2 instances, where you are using VMs and setting up yourself, right, everyone? Where you are setting everything yourself. So this is a way you can do it. So in case if you want to dig more, do it yourself, you can do it. There is no problem, right? I'm sharing this link as well. These are important links. In case if you want to upskill your career in entire Kubernetes stuff, these things will become important, right? As of now, it may look complex, but later on, when you keep on working with this will give or become a piece of cake for you, right? So now let's say we go to the whiteboard again. Now, what else? I think installation part we will do directly on AWS, but I think we have, okay, so one of the questions which is asked in interviews is describing the working of the Kubernetes, right? Describe the working of Kubernetes because you have seen the entire architecture. So if I want to ask you what is the working of Kubernetes, because I explained you in the form of a flow. So I covered both of the things, right? So according to you, what will happen? How this thing will work, or how your Kubernetes cluster will work? Come on, everyone. No idea?
Sir, we give commands with kubectl and we run pods on nodes. It's all.
We give,
We give commands with kubectl
okay, kubectl, right?
and
Which
yes, kubectl, yes.
yeah. So
And
that kubectl is for working with the Kubernetes, right? So in case if I am explaining, let's say if there is any kind of developer which is there and he's asking about, and there is someone who asked in the chat, I saw that, okay, that you have seen there are nodes, multiple nodes can be inside pods. I think who asked that question earlier?
I, I ask multiple containers inside a pod.
Yes. So whenever you are saying that multiple containers in a pod, you have heard about replicas, right? So
Yes,
what
sir.
you couple those containers. When you are coupling the containers, then you can say that okay, there are multiple containers in a pod. But ideally, pod is equal to container when you are running standalone applications, right? When you couple
Yes, sir.
everything together, right? You, in case if you are reading somewhere, you will find that word coupling over that we couple several containers and that can be present as a pod, right?
Yes, yes.
So that coupling word is very important. You couple everything. And when coupling is there, what happens? That pod cannot be used for different thing. So when you are using the same multiple pods, sorry, multiple containers for doing one job only, that is coupled together to do some the same task. So unless and until that task is completed, all the coupled containers will continuously running. It will not be ended. But in rest of the pods, what will happen? If the task is completed, the pod will go away. Is that right?
Yes, sir.
Correct? So when you have multiple containers inside a pod, they are coupled together to work. Clear?
Yes, sir.
Right? So when you have this kubectl command, ultimately what you're doing, you are trying to build some service, right? Right? And those services you're using to either load balance your traffic on your pods or some kind of strategy you're using, let's say round robin distribution in your healthy pods, because there can be let's say 200 pods, but if there are only healthy pods are 100, right? So what will happen? If healthy pods are 100, my traffic will go only to the healthy pods, correct? So if you have, let's say, uh, how to draw it? Let's say you have a user who is coming to my Kubernetes cluster, right? Who is coming to my Kubernetes cluster. Let's say there is a ingress traffic or a ingress controller you're using. You must have heard about this ingress controller, correct? So this is coming inside, correct? Now you have created a, let's say, Learnbay application, right? And in Learnbay application, what you have done, you have several components in which you have created multiple service And the service use case is what? To distribute the load, right? So one service is this, the other service is this. Correct? So the ingress traffic is being sent to this service, and it is also sent to this service. Correct? Now, when you have these services available, let's say Learnbay is placing some live recordings, right? We have the live recordings. So let's say they have hosted their page. On one place, they are keeping their live video recordings, right? Learnbay live video recordings. And one side they are doing, they have Learnbay images, right? So this service you are using for image processing, right? And this is you are using for video processing, correct? Now this service will be distributing traffic on various pods, right? Various pods. So there will be several pods. Let's say this is my one pod. Let's copy and create multiple pods. Okay, so let's say this is your pod, right? And just like we were talking about coupling, let's say I've coupled this pod for one task. So they are just coupled and I've replicated the pod. This is the replica of the same pod, replica 2, and this is the same task. This is replica 3, right? Now this is another service, right? So what we are doing, this is my pod. This is again replica 1. This is pod, replica 2, and this is pod, replica 3, right? So what you can do, you can redirect your request to these several pods on the basis of the strategy which you're following. Let's say round robin you're following, or you are following, let's say some ratio, correct? Usually it is round robin that, okay, according to the traffic, if the servers are idle, you will keep on sending. And similarly, you will follow the strategy over here. You will keep on distributing the load to the respective. So this service part which you see over here, that is responsible for distributing to the load onto the Kubernetes cluster, right? So the ingress is something that is allowing access to your Kubernetes services, right? This ingress which you see, this is allowing access to the Kubernetes service, right? First thing, from outside of the Kubernetes cluster, from outside of Kubernetes cluster, right? Outside of Kubernetes cluster. Also, in case if we want to configure access by creating some collection of rules, right? Or there are some definition which you're defining that, okay, which inbound connections will reach your services and which will not, that you can also define, right? So you can configure, this was the first point, right? Second, you can configure access by creating a collection of rules, right? That clearly define or that define which inbound connection reach which service, right? Which inbound connection reach which services. So I have used two services. This is my service one and this is my service two ideally. So my inbound connection is going to which service, that is I'm defining on the basis of the rules, right? That which service you should go. Either you should go to learnbay.co/images, right? So this path is for this service. This is learnbay.co/video. This is going to this service. So who is defining these connections? I am defining this, right? So that is how your entire Kubernetes cluster will send the traffic to the respective ones, right? And if this was only the flow of the traffic which is happening onto your cluster, right? But what about the deployment in Kubernetes cluster? You have heard about deployments in Kubernetes. So what is deployment? So when you talk about deployment in Kubernetes, actually these are some terminologies which Kubernetes uses, right? That is why I'm using deployments in Kubernetes. Right? So this is acting basically as a controller. That is why I'm defining it. So this is basically a controller. Just like you have node controller, right? Similarly, this is a controller which is there. What is the use of the controller? This is helping your applications to reach a specific state, right? And that state you have defined as a part of the deployment file. So what do? You have a deployment file, let's say. Correct? In this deployment file, you will have various parameters are there, right? That okay, what is the desired state is there, or what is the syntax file you will define, right? It will be all in YAML code, which is there. Let me see if I have a file or a version which is there. Let me just see that. Let's say I use this, right? Control A, sorry, Control C. Will I be able to add it? Insert text box. Let me see if it can come in one page or not. No. Why so? Let's use only half of it, right? Okay. So there is my deployment file which is there. So in this deployment file, basically it's a YAML syntax which you're using for deployment is a YAML. Let me just come into this. YAML syntax for the deployment. Correct? Now, when you use this YAML file, this you see replica I'm using as 1. If I change this replica to 3, it will deploy 3 pods. For what? Here I'm using the image as Redis, right? If you see, this image is what? It is Redis. Correct? So if I create the replica, what will happen? It will create 3 replicas. If I change it to 3, it will create 3 pods for same image, right? And it will try to maintain, because this is all defined as a part of the specifications, right? So its specifications is, if it is set to 1, then it will run 1. Let's say if it is 3, then it will try to maintain the desired state, which is the 3 pods, until the deployment is deleted, right? So this specification which you see over here, this will try to maintain the desired state until the deployment is deleted, right? Until this deployment is deleted. So I have kept 1, but let's say if I will make it 3, then it is considering that, okay, we should have 3 pods, right? Whatever environment you're using, I'm not focusing on that, but whatever environment you're using, it will use 3 pods, and it will remain, or it will consider that as a desired state until and unless your deployment is being removed, right? So whenever you hear this word in deployment in Kubernetes, don't just think that, okay, we are deploying Kubernetes, right? They are talking about a deployment file, right? They are talking about what? They are talking about a deployment file, and what you are placing inside this deployment file, right? In this, you are defining that, okay, if your application is getting utilized, it will, or it should reach the desired state. And what is that desired state? Let me write it over here. Your requirement is, or when you are doing the deployment in the Kubernetes, it is a controller. It is a controller, right? And which is helping, or which helps. Let me just move this below. Let's say which helps your applications, which helps your applications reach the desired state, which reach the desired state, and desired state is correct. Reach the desired state, and the desired state it is defined, sorry, is defined inside the deployment file, right? Correct. It is defined inside the deployment file is there. So if you have, let's say, a deployment file in which, how to draw, let's say right? Let's say this is my deployment, correct? And in deployment, if I have defined one, right? If I have defined one, then it will be one. If I have defined three, it will be the three containers sitting as a part of my deployment, right? Three containers or three pods which are sitting inside my deployment, which you can add over here. These are my pods. Correct, everyone? So reaching the desired state will completely depend upon the deployment file and the desired state which we have defined inside the command file.
So where we define that how many child node is present or not, this is only pods, right? So where we decide that one,
How many?
how many nodes?
So that we define as a part of your cluster configuration,
Okay,
right?
okay.
When you define the auto scaling mode, there you define the nodes and what is the maximum instance count, minimum instance count, just like you do in auto scaling, right?
Hmm.
That you
Okay,
define over there because Kubernetes at the backend is using auto scaling. And for that, it will need a auto scaling group running at the backend, correct?
okay.
Right?
And this YAML file, this is a deployment file, right? So whenever I require to deploy some application into stage environment or prod environment, so that time we create one deployment file. There we specified all the necessary things like this residing states, nodes, and everything, and that's the way we deploy that application to production server and all.
But why to mix that at this point of time? Why are you bringing the CI/CD pipeline at this point of time?
But you mentioned deployment file. That's what I just so deployment file. How only
Okay.
this nodes and
So
pods and all that. That's
what
only
is
thing.
the deployment file? What are we using this for?
How many nodes and all is required? How many pods are all required?
Right?
And basically, which OS is required? So
Right?
that is
Is there
specified.
anywhere you feel that it is anywhere related to code deploy?
Okay, no.
So will anywhere your pipeline come?
Okay, okay. Yeah.
Okay. We are still at the Kubernetes, how we'll deploy the Kubernetes cluster. If you are thinking to deploy it as a pipeline, the process will again be the same. There we did onto the EC2 environment, right? Now replace the EC2 environment with Kubernetes. The
Mhm.
pipeline will deploy on Kubernetes,
Okay, okay. Yeah, good.
right? Okay, so we were where? Okay, so you're talking about the deployment part. Now, whenever you are working with your deployment, you have to, first thing is what? You have to create a service, and that service responsibility, I have clearly told that which service you are using over here. The service responsibility, right? Let me just write it over here. So when you are creating, or let's say write service, or when you are creating this service over there inside the Kubernetes cluster, let me write this as this box, then you'll be able to relate. So when you are creating a service, so service is a helping you in load balancing, right? So this service is nothing but it is a round robin load balancer for all pods, right? It's a round robin load balancer for all pods, which is there. And it is matching either with the name, right? Or the purpose why we are using it, right? So it is constantly monitoring the pod. So if you have a service, if you go to the top, right? Let me just take this part from here. So what are we saying? We are saying that's a round robin load balancer for all the pods, right? Now, along with that, it is doing what? It is constantly monitoring all the pods, constantly monitoring all the pods, right? And in case if there is a pod which is getting unhealthy, the service will start deploying the traffic to the other healthy pods, right? So let's say this pod is, unhealthy, right? So what will happen? This traffic will not go over on this pods. It will not go over here. So now this will keep on sending. It will now in case the pod is unhealthy, it will start sending the traffic to healthy pods because it is doing the health check, right? This is also responsible for health check, right? This is responsible for health check because ultimately this is a load balancer only, right? Health checks. They are just trying to complex things. Ideally, the role is what? This service is equal to load balancer only. This is a round robin load balancer. But they wanted to evolve their own terminology, so they start confusing people by different names. That okay, this is a service. But ideally, it is a load balancer only, which is responsible of sending the traffic to the pods. Previously, what we were doing, we were sending the traffic to the VMs, but here we are sending the traffic to the containers, right? Here we are sending the traffic to the containers. Now, when you are defining the service types, right? And you're using this service, so the service types are first is your cluster IP, right? So this is exposing the service on cluster internal IP address, right? So it is exposing service on the cluster internal IP. Correct? Other thing is what? Other thing is your node port. Other is your node port. So what this node port is doing? This is exposing the service on each node's IP at a static port, right? Here it is doing what? It is exposing service on each nodes. Node is what? VMs, right? Each node's IPs on, or let's say, so if the port is HTTP, or HTTPS. So it will go and give it or mention at a static port. So at a static port, correct? Now third thing, one was cluster IP, node port, other is your load balancer. How are we using the service? So if it is load balancer, then it is exposing the services. It is exposing the service externally using a cloud provider's load balancer, right? So that was the use case when you are using the service type as your load balancer. So these are just the types, right? Don't consider that, okay, there is a component which is coming. This is the type of the services which they are defining. And then you have external name. They have to create the categories, right? Then there is an external name. So what are we doing with the external name? You're mapping the service to the contents which are sitting as a part of the external name. So maps the service to the contents of external name. Right, everyone? So depending upon the type of service you're using, you will keep on sending the traffic to the respective pods or the service which is there, right? And when you are creating any type of service, let's say you're creating a node port service, right? So node port service would be kubectl create service, node port, nginx, and the port number which you're using. So it will just create a service, right? So multiple ways by which you can create service. So we'll see next time what are the ways of creating a node port service, what is ingress, how the ingress is being used, what is ingress controller, how we are installing the ingress controller, what are the ingress rules, right? So all those things we will be discussing in the next class, right? So please make sure that you revise everything so that we are able to discuss these things in the next class. And then we also deploy the Kubernetes cluster. Make sense, everyone? Okay. So let me just quickly share this file with everyone.
Abhinay, one question. So that YAML file, you added that you specify that how many pods and all. But actually, Kubernetes itself have the capability to how many pods is required using AST and all, right? So the why we need to specify that in specifically in the YAML file?
So we are defining just like you define the state of the cluster, right? Just like
Okay.
you define the state of the okay. So you have learned auto scaling, right?
Mm.
In auto scaling, you define that okay, this is my desired state, right? This is the initial capacity. This is my desired capacity. So
Oh,
you have to answer me, why did you define desired capacity in auto scaling?
so that is a default thing we required.
No, it is not default thing. It is the same concept why we use desired capacity. So you have to tell me, why did we use desired capacity in auto scaling? So that is a question for you for tomorrow. You have to come
Okay.
back with the answer and then we'll discuss. Okay.
And one more thing. So Kubernetes we need to deploy in AWS only, right?
Yeah, we'll develop videos.
AWS. Okay.
And what is this service types? I'm not clear. So cluster IPs are like what it will do?
So just like you have an IP defined on as a private IP on the load balancer or the cluster, so it is referring
Mm-hmm.
to the IP that if in case if you want to send the traffic from the user, you send that traffic onto this cluster IP. This service is
In
the
from
reference.
inside the cluster to outside, huh?
So consider this as a when you have an internal application, then this is the one which is using, right? Consider this diagram. This is the place where you are receiving the traffic from ingress, right? So when you use an ingress, you send the traffic to at some point, right, on the service. Either it will be a node port, either it will be a IP, either it will be a load balancer, either it will be a custom thing, right? So those things we are discussing over here. That when you send the traffic from ingress, where you will be sending it on the service, or what type of service you will be selecting.
Mm-hmm. Okay, this is one layer before Kubernetes, service, because pod comes
Inside,
after the service, right?
this is inside your Kubernetes.
Okay, okay, okay.
We are now moving towards, so that was the architecture, right? That was the architecture, how everything is working. Now we are talking about working of the Kubernetes, how it is internally working.
Oh, okay.
Correct? When you send the traffic from ingress controller to service, right? So there must be multiple ways of sending, just like you send traffic on IP, you send in traffic on port, you send the traffic on external name, you send the traffic on load balancer. So these are the various categories we have. That when you are sending the traffic from ingress to the service, these are the things which you can keep as destination. Get
Okay,
the
either
point?
you can send to cluster IP or node port, depends,
Or
right?
load balancer or the external name. These
Node
are the
balancer.
things by which
Okay,
you can redirect the traffic. You are
okay,
doing the redirection, right?
okay. There it will consume the traffic and allow to the ports.
Yes, correct.
Okay.
So in case that should be in the master container, master VM, it should be reside, and they will control all the ports, something like that.
No, see, ultimately when you're running in the cluster, now we are at a point where we are redirecting the traffic, right? Now redirecting the traffic will happen on the pods, right?
Yeah.
You are redirecting the traffic. Now the cluster you're exposing with the IP address, right? So there will be an IP on the crew proxy, or the, let's say, name on the DNS, or there will be four nodes and there is a load balancer attached to towards the four nodes. So there can be multiple scenarios, right?
Hmm.
Once we run the Kubernetes cluster, then it will be more clear,
Okay.
right? If I leave these concepts and directly jump onto the practical, then it will be even more complex,
Okay.
right? Fair enough. So let me just, okay, I every day I upload the file on the this drive, right? But I see there is no one who is downloading the notes. No one
I
is.
did that. I did that.
So then why I'm seeing that only no response on this? Because Princy can easily see who all accessed the file.
Today only I downloaded it.
Yeah, I think I don't think so. Google will provide such information.
No, no, no. It is
Number
providing.
of downloads.
No, not the number of downloads, the people who access the file. So the
Okay, what happens if you open that and stay on that page simultaneously? Then you can see the number of viewers.
okay. Otherwise they cannot see, right?
Otherwise they can't see.
It will see. I'm not sure. I am not the owner, so I cannot see it. But, because I was seeing that whether the people are able to download or not.
No, that download you won't get that information. Yeah, if you're viewing at the same time, then obviously you can see that.
Is it different folder I'm seeing or not? I think I'm on the right folder, right?
Yeah,
So should I share in the chat or on the drive?
drive only.
Or drive only. Okay, let me just quickly share on the drive. Okay, how many days we had sessions on this DevOps? I think from first we started. So how many days we had the session? Can anyone is keeping the track?
Excluding Saturday, Friday. I mean Saturday, Sunday. It's we are running 2, 3, 4, 4. 20, 22 class, I guess. 22 sessions.
Right?
Approximately 22.
Okay. Yeah, we had holidays in between too.
August 15th,
The
that holiday
timelines
also.
they have given, what are the timelines they have given you for completion that we have to complete, because I think this will stretch a bit, right? I will need additional 10 to 12 classes for the entire this, right? I think that is fine for everyone, right?
Yes, fine.
Everyone is fine with that, because
2 more weeks, right?
yeah, at least 2 more weeks, at least, right? It will go beyond that, but at least
Hmm.
2 to 3 weeks it will
To
take
complete the Kubernetes or all DevOps?
to hold DevOps.
Okay. Yeah, no
Today
problem.
class of this DevOps session.
Sorry,
This is the 18th class of this DevOps.
it is the 18th class of DevOps session. Okay.
Yes.
Yeah, so then we have enough time, right? We have enough time. So at least I would need additional classes, because we have to do practice of this. Then we have to talk a bit about Terraform as well. So a lot of things we have to do. We have to talk.
After this DevOps, we have Splunk.
Uh,
Yes, sir.
Splunk I would not be taking, because Splunk I have read myself, but I have not taught before, right? So,
Okay.
They
so
try to taught us.
sorry. Yes.
They said
Yeah.
taught us.
Now try teaching us. Okay.
Actually,
But
I
but Splunk, what we need to learn, because I don't see much in Splunk. Just the project management kind of thing, right?
there are a lot of things in Splunk, right? It is the management part of the thing, but there are a lot of things, right, which is there. I can give you a basic overview of that, and then it will be clear, right? It's more of a deployment part and the management part, which is there in Splunk. So, but it is good to use, right?
Hmm.
No, I'm asking like after DevOps, Splunk. That's it, right? We're done with the course.
There is Elastic. Means I think there is a lot of components. If I go to where?
Because
There is
the topics are huge and we are not getting proper time to revise.
anyone who has the yeah, this is the one. I am thinking that too much is left, and but you all are saying less is left. But if I go to the paper part, if I
We
go,
don't know what is Kubernetes, and also we are not sure that how it is.
everyone is getting understanding what Kubernetes is, right? I know it is complex, right? There are very less people who understand in one or two classes, right? So are you getting whatever we are discussing?
Yeah, we are getting some idea on that.
So see, Azure DevOps itself will take. I am pretty much sure it will take.
Azure DevOps, it's optional.
It is optional, right? But
Yeah.
okay, if it
That
is
is an
optional,
option only.
right? This will take at least 10 to 12 hours, right? Because you have to
Okay, 10
start
to
from
12
one.
hours means 1 week. Mm.
Yeah.
Mm.
And alerting
1
mechanism,
week,
event bridge, and everything
integrity
like that.
monitoring and automated.
This is completely.
Okay. Elasticsearch, Logstash, Kibana. How many class this one?
This is just overview, because what these services are doing, what we are doing. Because for this, we require the entire setup for environment, right? Where you have monitoring devices, you bring those devices into this, right? You have Kibana licenses. So you set up and monitoring for dashboards, right? So that is a service which you have to use, right? And then only, right.
Just the overview.
This is an overview which will cover that how Elasticsearch is working, right?
Okay.
So that is what we will be doing. Then
Okay.
this we are already doing, right?
Uh-huh.
Jenkins, I have to cover, right? This one is
Okay.
also covered, right?
That
So
is
for
also covered, huh? That needs to be covered, right?
no, this part is left, right?
Puppet, yeah, we are done. Yeah.
Ansible, Jenkins, at least means one playbook we should be aware. REST Puppet is like a integration you do like Jenkins. So you do with a manifest file and everything that is there. We can go through there. Main thing is the concept is very much important, both Puppet, Ansible and Jenkins. One small labs will be enough to clarify the document, but in concepts in Ansible and Puppet and Jenkins, they are huge, right? Just like you saw the concepts here in Kubernetes, Kubernetes deployment is 20 minutes in cloud. But when you learn Kubernetes, it is so much. See, we started, I'm not sure how much time it will take more.
Sir, Chef is a different service, sir.
Sorry?
Chef. Is Chef and Puppet same or different?
Different. Oh, they are integrated, but they are different. Don't demystify everything. I want to cover that, right? So ask everything now.
Puppet is basically monitoring tool or something? No, right?
No.
Grafana is a monitoring tool, right?
Monitoring tool is Grafana, Kibana, Elasticsearch, right? These are monitoring tools.
Okay, so Puppet is basically
Configuration management tools.
okay.
Right?
Configuration.
Deployment and configuration management.
Then Terraform.
Terraform is IAC. So we'll talk about the basics of the architecture of the language, right? How the language was created, what all things, how we execute the command, what is Terraform init, what is plan, what is apply, what is Terraform means. There are various stages, right? Init, plan, deploy, something like that. There are a lot of stages. And we will be discussing then how we can deploy the code using Terraform. So that will take at least 10 hours.
So this deployment file, whatever you mentioned, right? That also they will create with the using Terraform only, right? No.
So the deployment file, you can, once you have this deployment file, you can run the application on the Kubernetes cluster. So you can do that via the pipeline as well. You can do that via, let's say, your IAC as well, infrastructure as a code as well.